Hello, I'm Stefan Graeber. I'm the project leader for LexD. And in the previous video, we looked at using a service called Candid to allow for external authentication into LexD. Candid made it possible to connect to, in the case of the demo, either a local set of just hard-coded usernames and passwords or the Ubuntu SSO service. It can also connect to a number of OpenID Connect providers, as well as OAuth and more generally LDAP and Active Directory. With Candid, it was a bit of an all or nothing kind of deal. Either you had credentials that were valid and Candid would give you access to all of LexD, or you didn't and you would get nothing. That didn't, like Candid on its own doesn't really let you choose what LexD project you might be able to access to or what permissions a given user might have in a particular project. That's where another service called Canonical RBAC kind of comes into play, and that's what we're going to be looking at in this video. Now, there's a bit of a disclaimer right there. As the name might imply, it's Canonical RBAC service, and it is a paid service. So you need to have an Ubuntu Advantage infrastructure subscription to be provided access to the package that lets you install and run that particular server. Once you've got access to the package, you're good effectively, and the instructions in this video will work for you. But if you don't have a Ubuntu Advantage subscription, then you won't have access to this particular feature. LexD itself acts as a client to that service, and all of the client side of it is all open source, so there's no separate build of LexD or anything weird going on that front. It's just you need to have access to this particular service, and it is part of a paid subscription with Canonical. If you're interested, so that's the page on the Ubuntu website for Ubuntu Advantage for infrastructure. That's got the details for what comes with it. It also, in this case, comes with access to support, professional support through Canonical for your host system running Ubuntu as well as LexD. Anyway, let's quickly see how that looks. So that's the Canonical RBAC deployment I've got for my home, my personal deployments. We can see here it's got a MAS cluster defined in it, and then a number of LexD, a couple of LexD clusters, and a number of standalone LexD servers. Canonical RBAC was designed and implemented by the MAS team initially, so that's why we've got MAS in there. And then LexD support was also added. So that's currently the two products it supports. It might grow to support more Canonical products at some point in the future. Now, what that looks like on the LexD front is you get the list of all of your projects here. That's synced with LexD. And then for each project, so say I take, where is it? I can take this one. Then on a given project, you can assign individual users or groups the permissions of admin, operator, user, or auditor. And if we look at this one, if we scroll down a whole lot, we're going to eventually see the user that's actually got access to this project. Here, you can see that this user has the operator permission. Clicking on one of the roles up there, so not actually permission, one of the roles, so operator in this case, you see the definition of it. So in MAS, it gives you those particular permissions. In LexD, being an operator gets you this set of permissions. And then on the right, you can see who has access, to what service with, and then specifically within the service, what project or what resource pool the person has access to at that level. So in this case for admin, it's pretty much just me. Operator, I've got a bunch. User, I've got a couple of cases, mostly against the test server we use to validate this. And then auditor. In the case of LexD, roughly the way that works is auditor is just view only. You don't get to actually access anything. You don't get to modify anything. User, you get to access what's already there, but you don't get to create anything at all. Operator lets you create things, but you don't have the permissions to grant yourself more permissions. So like you can't reconfigure a project, for example, or you can't reconfigure the entire server. So that's roughly how that works. Now let's go look at how to set this stuff up. All right, so what I'm looking at here is a cluster that's very, very similar to the one that was set up in the previous video. In the previous video, it was a cluster of 3 Raspberry Pis that was then used to deploy Candid. Because the Canonical RBAC service is only distributed as Intel binaries, that was not going to work. So I recreated the exact same cluster, but on Intel virtual machines instead. So if we look, with a typo, we can still see a Candid container running, and it's got the exact same configuration as was showed in that previous video. I can also look at the service config, and we can see it's configured here to access Candid for authentication. All right, so now to play with RBAC itself. So I've got this new container called CRBS. That's also an Ubuntu 2004 container, and it does have the Canonical RBAC package installed. So that's what you get access to as part of the subscription. In this case, I'm using my own access, so it's actually using a beta version, not an actual stable version. But anyway, there are different tracks and channels, and this one is running on beta. So once that package is installed, it pulls in a few things. It installs Postgres automatically, and it also installs Candid. Because we already have Candid installed in a separate container, we're just going to be removing it from this one. And then, as I said, Postgres came as part of the installation, but has not been configured. So we're going to be creating a new user called CRBS, give it a password, then create a new database also called CRBS that's owned by that user. Just on acronyms here, CRBS stands for Canonical RBAC Service, and RBAC itself stands for Role-Based Access Control. With that done, now we need to actually connect the Canonical RBAC Service to Candid. Because Candid is going to still be used for all authentication, and then authorization is going to be handled by Canonical RBAC. So first we need to grab some credentials. I'm going to go into the Candid container and then grab its admin keyring. So this, and then go back into the CRBS container, make a candid.keys file and copy paste that data across. One thing here that's worth noting is this line. Make sure that it is correct. It needs to be the right URL to access Candid. If it's not, then the next step is gonna fail. With that done, then we need to create a Candid agent. So that's effectively the registering RBAC with Candid and giving it an account that's got enough permissions to list all users and their groups. So for that, you need to pass the admin key, and that will generate a new service key. The admin keys are no longer needed, so we can delete them from disk to avoid having those lying around. And then we can do Canonical RBAC init. Okay, and this asks for the database credentials. So that's what I entered earlier. Then the public address for the service. So this is HTTP, the IP address of the instance, and then the port. The port for RBAC is 5000, so that's what that looks like. And then it asks for the service keys. So give it the path. And it's gonna initialize the database, connect to Candid, create whatever it needs to create over there, pull some initial users and groups, and then we're done. Next step is to create an administrator account, because right now RBAC is functional, but it doesn't know who's an admin, so nobody can actually connect and configure it. For that, I'm going to use Canonical RBAC create admin, and that's going to give us a link to log in. So I'm just going to run that command, then take the URL it gives me, and go and open that in my web browser and log in. So that sends me to Ubuntu SSO, I do login, and I'm done. Now, Canonical RBAC is effectively loading that into the database and making me an admin. Takes a little while, and then we're gonna see, there you go, created admin with username Instagrammer. So that's all good. And one last bit we're gonna need later is need to kind of similar to Candid, because we're not going to be running this on HTTPS, we need its public key. So doing a curl, using curl to get the information. So that's the RBAC URL /o/discharge/info, and that gives us its public key here. That's going to be used in just a little while. Now we can go look at RBAC itself. So I'm going to be using here, hitting it up with my web browser, do login, authenticate with Ubuntu SSO again, logged in, and here we go. That's the welcome screen. So it says add a service because there's nothing in there. So let's do that. Choose LexD as the service, enter a name. No need to specify an admin. It's fine. Okay. Now the service is created. We can see that orange dot here that says that the service is created, but the service has never actually connected to RBAC. So something is misconfigured. To make that work, we need to click on services at the top left and then do generate credentials at the top right. This will create the credentials we need to feed LexD to connect to the service. So between what we see on screen here and what I got earlier with curl, we've got all the information needed to configure LexD. So I'm gonna go out of the container and into LexD itself, look at its configuration, and then unset the Candid configuration keys. Oops, keep forgetting. Okay, so like that. I'm just gonna be copy pasting that public key so that when I clear my screen, I don't lose it. All right. And next we're gonna be actually setting up RBAC. So let's do, those are all the configuration keys we need to set. So private key, the private key is this one. So copying that one over. Okay, then RBAC agent public key. Same deal with the public key here. Then RBAC agent URL is this one. Then RBAC agent username is that one. RBAC API URL is the RBAC server itself. So that's that. And RBAC API key. That's the one that we got earlier through curl. So it's this one. And with all of that set, now LexD should connect to RBAC. So if we go back in the RBAC UI and just refresh it. Oops. There we go. We can see that the orange dot is gone and the project list has been refreshed now. So looking at LexD, you can see that the project list I've got matches. I've got foo, bar, and default. If I go and create a new project called bars, and I refresh the UI in RBAC, you can see the project shows up. So that's all good. Now let's add that cluster. I should probably have kept that shell open actually. Anyway, there we go. So remote add demo, and that's that URL. That once again asks me to log in. So if I open the URL here, so I do again Ubuntu SSO, yes, log me in. Oops, I probably was too slow. That because another web browser actually opened the URL initially, so I think that probably was the issue. Let me just do it again. Come on, Ubuntu SSO login. Yeah, there we go. Now I've got that remote added, but let's see just how much I can see. So not a whole lot. I suspect I can't even list the projects. Well, I can, but I don't see any project. So that's normal. My user doesn't actually have anything configured right now. So say I wanted to just be able to see foo. I'm gonna have to find myself in that list all the way there. And let's just give myself access as a user in foo. And I'll give myself access as an operator in bar. And let's do as an admin in bars. Okay. And now I can see all 3 projects show up in LexD. Actually just clear that so it shows up at the top. But we quickly see what the limitations are. So if I do the most simple, let's create an empty container. And I try to do that in foo. Demo and project foo. I'm not allowed to create because in foo, I'm just a user. So user is not allowed to create stuff. And if I do the same thing in bar, this will work. But it's currently not working because the default profile has not been set up. That's normal. And in bars, the same result should happen. The difference here being that I can edit. So if I do an edit on demo bar, and I don't know, let's turn off the storage volumes. Well, actually, no, it's something useful. Let's turn off the profiles. This also fails because I'm only an operator, and operator is not allowed to reconfigure projects. But now if I do the same thing against bars, in which I am a full admin, then in this one, I'll be allowed to do it. And as I've done that, that means that I no longer have profiles be separate in that project, so I should actually be able to create an instance because it will just use the normal default profile. There we go. The other thing I shouldn't be able to do, that's my own machine. I actually want to do it on the remote one. Right, so if I look at the config for demo, it shows nothing. That's because in RBAC, if we go see up here in global access for me is absolutely nothing. So I'm not allowed to actually do any of that. Now let's try to just give myself basic read-only access. Still not a whole lot, because those are effectively marked as sensitive keys, so that we don't actually let you list any of that. But if I make myself an admin, there we go. Now I can actually control LexD, and that also means that now that I'm an admin, I can create storage pools, reconfigure networks, do all of that kind of stuff, which is also otherwise not allowed. And as an admin, if I don't want to have to go and like grant myself access project by project, what I can do here is just click on all projects and then grant myself admin access to everything. And now if a new project is created, let's create a project called blah, and I try to create an empty instance in blah. It works. I mean, it works with an error because again, the default profile has not been configured in there, but it does work. And I could then do the same thing where as my user, I can go and edit permissions and configuration of the project, and then I can create an instance in there. So that's kind of that's really trying to show you the integration and how that works. Like RBAC is pretty convenient with the way it's integrated with LexD because it works mostly live. Like in this case, my user never needed to re-authenticate in between changes. As an administrator in RBAC, I went and changed some permissions, and that was live applied to the user. The user then immediately had access to those things. Similarly, if the user was revoked or their access removed, they would immediately lose the ability to do any of that. So say I can, currently list everything, it's all good. Let's revoke my access to all projects. Let's revoke myself my admin access, and let's revoke. I didn't actually have permission to access default in the first place, so now that's gone. And I'm no longer authorized to do it. And similarly, if I now grant myself just basic read permissions on there, I'm allowed to list stuff again, but if I try to actually interact with anything, I'm not authorized to do it. So that really shows like it's very flexible. We can very easily modify permissions for everything. LexD gets notified, changes permissions automatically. And similarly to just the pure Candid setup that I showed in a previous video, it's quite convenient for LexD because LexD doesn't really need to know much. Like LexD itself doesn't have really the notion of access control and of who is who and what things they can access and what group they're in and all of that kind of stuff. All that LexD knows is, okay, this person, well, this user is talking to me and that's their permissions. And if the permission change, then access changes. So I hope this was useful to you as a way to see how you can manage access on a pretty complex LexD deployment and some of the flexibility that comes with it. Again, if you're interested in this, you do need an Ubuntu Advantage infrastructure subscription. If you do have that, then you need to reach out to support to get access to the service and the packages themselves, and then you can deploy as was showed here. I hope this was useful. If you got any questions, you can leave in the comment section below or on our community forum. Thank you for watching. Bye.